Hello everyone, my name is Stefan and now let's take a practical look at an example of SCADA software and attempt to exploit it using Metasploit. In this case, we will focus on exploiting a DataC Real-Win SCADA Server 2.0 system running on a Windows XP platform. So this service operates on port 912 and possesses a vulnerability related to buffer overflow with the sprintf function. Now let's actually make the Windows XP view smaller, make it on the right side here. And also we had some text here. Yeah, that's it. And now what we're gonna do here is go back to our attacker machine. So here, this sprintf function utilized in DataC Real-Win SCADA service source code is responsible for constructing a specific string based on a user input. So when a malicious manipulated by an attacker, this vulnerable function can lead to a complete compromise of the target system. So now we will use the exploit Real-Win SCPC initialize exploit because it specifically targets vulnerabilities within the Real-Win SCADA systems. So use exploit Windows SCADA Real-Win. Actually, can you hear my voice? Yes, perfect. So Real-Win SPCP initialize. So exploit Windows SCADA Real-Win SCPC initialize here, and let's show options. And as you can see here, it automatically selected the Metasploiter reverse shell for us, and I will explain that right now. So the Real-Win SCPC initialize exploit is tailored to a particular SCADA system, Real-Win. By focusing on a specific system, we can better understand the intricacies of that system's vulnerabilities and assessment its security accurately. So Real-Win SCADA is a real-world system used in industrial and critical infrastructure settings. So by testing its security, we simulate scenarios that are relevant to actual industrial environments, helping us identify and mitigate vulnerabilities that could pose significant risks. So this exploit provides an educational opportunity for students and penetration testers. It allows them to gain hands-on experience in identifying, exploiting, and securing vulnerabilities in SCADA systems, which are crucial for safeguarding critical infrastructure. So the exploitation of SCADA systems is in infrastructural control systems environments is growing concern due to the potential impact on public safety and the economy. So by using this exploit, we can assess the security of ICS components, helping organizations identify weaknesses and develop stronger defenses. So this exploit aligns with the specific vulnerabilities found in the Real-Win SCADA systems, demonstrating the importance of tailoring penetration testing to be unique characteristics of the target environment. So it emphasizes the need to use relevant exploits for effective testing. And in summary, using this exploit Windows SCADA Real-Win SCPC initialize exploit is vital in PenTesting ICS environments because it provides a targeted, real-world, and educational approach to identifying and addressing vulnerabilities that could have severe consequences if left unaddressed. And we will also use another exploits for deepening our understanding here. So now we will need to set the R host here. In this step, we will be gonna specify the target machine's IP address as the value for our host. In this case, our target machine was, let's actually see, the 142 and 137. So set our hosts here 192.168.1 142 and 138. 137 here. And after that, let's actually show the options here. We have set the all port. No, we didn't set, this is the default here. This is a listen port for interpreter here, a payload here, and we will also change this. And here module options, we have set the R host, so we will not change the R port here because this specific protocol, the specific service uses this 912 TCP port. And here we will also need to choose the payload. So the payload is a piece of code or software that we want to execute on the target's machine once we have exploited its vulnerability. Here we will choose the Windows Interpreter bind TCP payload here. So we will what we're going to do here, use payload here. It was use, or we use the bind TCP or reverse TCP here. But I think, however, the bind TCP is more reliable for this kind of jobs. Yeah, sure. We can use this bind TCP here. So set payload Windows here, interpreter bind TCP. That's it. Here we have already set this payload, and here the default port data serial win SCADA here. So show options. So the default port is 912. So ports are, so if you don't know what ports are like doors through which data enters or exits a computer or network. So in this context, the port 912 is the communication channel that the SCADA system uses. Now let's explain the overall goal here. So the objective here is to exploit a known vulnerability in real-win SCADA system running on a target machine with this IP address here. And we want to leverage this vulnerability to establish a connection to the target's machine remotely, giving us control over it. So to do this, we have selected this specific payload, which is designed to create a backdoor on the target system. And once the payload successfully executes, it opens a communication channel on port 912. So the default port data serial win SCADA, this is the default port for data serial SCADA. So this will allow us to remotely access and control the target machine completely. Now we will need to proceed with the exploiting the target to determine whether the vulnerability can be leveraged successfully. So this action will help us assess the security of SCADA systems and understand any potential risk associated with this vulnerability. Now let's proceed here, and as you can see here, the started bind TCP handler. Now we gained this interpreter shell here. That's perfect. We have successfully exploited this. Now we can do our things here, like we can set the load, we can use this load mimicuts here. So the first step involves loading the mimicuts model into our Metasploit environment. So this model is a powerful tool for post-exploitation tasks, particularly in extracting and manipulating credentials here. So we will load the mimicuts here. So load mimicuts here, and that's it. So mimicut has been replaced by Kiwi. Please use this in the future. Maybe we can also use the Kiwi here. It doesn't do this actually. They are almost the same here. So, and here, as you can see here, after loading the mimicuts model, we can utilize one of its specific commands here, which is Kerberos. Or let's actually show help, and yeah, we have list all Kerberos tickets. We have all of these commands here: hash dump, play, let's actually get the screenshot here. Screenshot. Let's see that screenshot. And as you can see here, we got the screenshot here, and we can also play this. This is fun actually. So we can, let's see what we can do. As you can see, we have a bunch of options we can do here. File system command, so we can read the contents of a file to the screen. We can print working directory and so on. We can also set the display interfaces, display the network connections. We have the system commands. We can clear the event log. This might be useful in some cases. And we can go to get the sys info here. This will give us the system info, the interpreter Windows version, and computer name. And the QV commands, we have the QV commands: retrieval credentials, use Kerberos ticket, purge any in-use Kerberos tickets, retrieve user account information via DSCS here. Retrieval credentials. Let's actually use this creds all. We can also change the password or hash of the user. Kerberos tick. Kerberos ticket list. We have not Kerberos tickets for now. Hash dump. we now have the hashes of administrators, guests, and the help assistant support. So if you are in a newer systems, you might like Windows 10 or 11, there will be problems for getting the plain text passwords from the system. In this case, we can also get the passwords completely because it's old and vulnerable machine in today's world. But however, it doesn't. We haven't modified this specific Windows XP here, but it's old and it hasn't had security patches like more than 10 years. So as you can see, we have the hashes of an administrator, guest, and support here. We can also get another here. So we can also brute force these hashes with John the Ripper, which we will do that in the next sections of our course. We can upload a file or a directory. We also have the networking commands. We have the system commands. We have the user interface commands. Remote user in a real time. Let's actually use a screen share. Let's see what it will give us. And here, as you can see here, can you see on the screen? Yeah. Now let's see what will happen. And as you can see here, we can see this screen real time here. Google.com. And as you can see here, we can do all kinds of things here, and that's it. That's a good exploitation here, right? So by following these steps, we can effectively load the Mimikatz model and use modules, all of the modules here almost. We can also go like, you can stop it now. Yeah. So as you can see here, we can uncover the system plaintext passwords also. We can actually uncover these passwords with Kerberos here. I think we missed something here. Help. So we can get this Kerberos creds all here. We can get QVCMD here. Threads Kerber. Wi-Fi list. We don't have Wi-Fi on this specific system. Cat use Kerber's ticket. Retrieve LM. Creds all. Creds MSV. Creds SSP and so on. You can also have another things here. Get elevate your privilege. Get system. You can go to shell, and as you can see here, now we are on the Windows system. CMD here. That's it. We have successfully hacked the system. And here we now have done with this lecture. In next lecture, we will have more specific and comprehensive penetration testings from now. So I'm waiting you in next lecture.